Hey everyone, in this video we're going to learn about the properties of quadratic functions. The best way to do that is to create a picture or a graph of a quadratic function. So our first example, graph the given function by creating a table of values. And the function is y equals x squared plus 2x minus 8. As a reminder, we know this is a quadratic function because it has degree 2. There's 3 terms. The highest degree of a single term is 2. Therefore, quadratic function. Now, we're going to create our table of values, so x and y. And the x values that we're going to input into the function are -4, -3, -2, -1, 0, 1, and 2. At first, that may seem like a random choice for the x values. Why not just go from -4 to +4? But there is a reason why I chose these particular x values, as we'll see when we graph the function. So if we input -4 into our function, we'd have -4 quantity squared, which is 16, minus 8 is 8, minus 8 is 0. -3 quantity squared is 9, minus 6 is 3, minus 8 is -5. -2 quantity squared is 4, minus 4 is 0, minus 8 is -8. -1 quantity squared is 1, minus 2 is -1, minus 8 is -9. 0 squared is 0, plus 0 is 0, minus 8 is -8. 1 squared is 1, plus 2 is 3, minus 8 is -5. 2 squared is 4, plus 4 is 8, minus 8 is 0. Now look at the y values. 0, -5, -8, -9, -8, -5, 0. There's symmetry in those y values. It seems that -1, -9 is the middle, and then from the middle, the y values are the same on either side. Well, what is that going to mean about our graph? I think the best way to answer that question is to graph the points. So we have -1, 2, 3, 4, 0, -3, -1, 2, 3, 4, 5, -2, -6, 7, 8, -1, -9, 0, -8, 1, -5, 2, 0. So there we have the points on the graph of this function, and if we connect the points, let's fix that last side. We have the graph of y equals x squared plus 2x minus 8. We refer to this curve as a parabola, and it's the graph of a quadratic function. Now what I want you to notice in this graph is if I take a vertical line and I go exactly down the middle, I need to move that over a little bit. If I go exactly down the middle, it splits the graph into 2 symmetric halves. So what we call that line that I just drew, we call it the axis of symmetry. It's the line that splits the graph into 2 symmetric halves. Also, I want you to notice that there's a turning point in the graph, a point where the graph goes from, in this case, decreasing to increasing, going down to going up. Now, it could be the other way. I could have that turning point up at the top, where it could be going up and then going back down. But in this particular function, that turning point is the lowest point on the graph, or a minimum point. All of these traits that we're starting to observe in this graph are important, and we're going to wind up finding them about every quadratic that we look at. Now, if we look back at that table of values, -1 was the middle of our table of values because that's the x value where the axis of symmetry was. And then I chose 3 values to the left and 3 values to the right of that x value. And I have a perfectly symmetric graph of the quadratic function. So we've defined quite a few terms, so let's formally define them. So our key terms: a parabola is the name given to the graph of a quadratic function. Vertex is the turning point of a parabola. This can be a maximum or a minimum point. And the axis of symmetry, abbreviated AOS, is the vertical line that goes through the vertex. The graph is symmetric with respect to this line. Okay, so essentially, if I draw the axis of symmetry and I folded a piece of paper along that line, the two halves would meet up as I fold the piece of paper. The reason the axis of symmetry is so helpful to us is if I can graph half of a parabola, then I can just take all those points and reflect them over the axis of symmetry, and I'd have my whole curve. So essentially I have to do half the work to get a full graph, which is a pretty nice feature. So now they've given us a graph of a different parabola. We can see this time the parabola opens down instead of opening up, like the example that we graphed in the first slide. So the graph of quadratic function is shown below. What is the vertex of the parabola? So the vertex is that turning point. So that's the point 2, 9. Is the vertex a maximum or minimum point? Well, looking at our graph, the vertex is the highest point on the graph. So it's a maximum. What is the axis of symmetry? So what is the equation of the vertical line that we can draw right through the middle of the graph? Well, if we wrote the equation of that vertical line, it would be x equals 2. Notice that x equals 2, the vertical line, and the x value of the vertex, which is 2, are the same. And that's an important feature that's going to help us find the vertex of a parabola if we know the axis of symmetry. Which point on the parabola is symmetric with the point 1, 8? Okay, so the point 1, 8 is right here. So the point that's symmetric to it is right there, which is 3, 8. Well, why is that the case? Well, that's the case because the axis of symmetry is exactly in the middle of those 2 points. They share the same y value. Okay, they need to reflect, right? If I folded this graph over the green line, they should match up. And x equals 1 is 1 away from x equals 2, which is the axis of symmetry. It's 1 to the left, so my symmetric point should be 1 to the right. So to the right of 2 would be positive 3. Okay, so all information that as we use this more is going to be easier for us to remember, but these are key facts about parabolas that are really helpful for us to create the graph from a function with as little work as possible. That's the key point there. A parabola has a vertex of negative 2, 1. What is the axis of symmetry? Well, we said the axis of symmetry is a vertical line that goes through the vertex. So they share the same x value. So the axis of symmetry is x equals negative 2. If the point 0, 5 is the y-intercept, state another point that must be on the graph of the quadratic function. Well, we've already talked about symmetric points having the same y value, so I need to find another point that has a y value of 5. Well, we know the axis of symmetry is negative 2, so if I was focused only on the x values, my axis of symmetry is negative 2. They've given me a point with an x value of 0. This is the axis of symmetry. So I need to find a point on the other side of the axis of symmetry that's the same distance away. So that's plus 2. So then I need to subtract 2 from the axis of symmetry, and we would get negative 4. So the point that's symmetric to 0, 5 is negative 4, 5. Right? It's all about those distances to the axis of symmetry. Based on the information given, is the vertex a maximum or minimum point, and justify your answer? Well, if we were to plot the 3 points that we have, we'd plot negative 2, 1, 0, 5, negative 4, 5. Well, these 2 points, the symmetric points, have y values that are larger than the y value of the vertex, so these 2 points would be above the vertex. Right? Those 2 points would be above the vertex, which means the vertex, the turning point, is going to be the minimum point on the graph. Minimum point, the symmetric points are above the vertex. Okay, so a lot of reasoning, a lot of thinking here. Next up, the 2 points on a parabola are 3, -3 and 7, -3. What is the equation of the axis of symmetry of the graph? So we have two symmetric points. We know that because their y values are the same. We need to find the axis of symmetry, which is exactly in the middle. Well, how do you find something that's exactly in the middle of two values? You find their average. Okay, so the axis of symmetry is x equals the average of 3 and 7. So that's 10 divided by 2, which is 5. So x equals 5. If you want to draw a number line to visualize it, this is our axis of symmetry that we're looking for. We know x equals 7 and x equals 3. Exactly in the middle of those two values is 5. A parabola has an axis of symmetry at x equals 1.5. If the points 10, 6 and k, 6 are on the parabola, what is the value of k? So again, we're given two symmetric points because they have the same y value. So we know the average of the x values would give us the axis of symmetry. So the average of 10 and k is going to give us the axis of symmetry, which is 1.5. So if we solve this, we can multiply both sides of the equation by 2. So we'd have 10 plus k equals 3. We can subtract 10 from both sides of the equation. So k equals -7. Perfect. So again, a lot of reasoning, a lot of thinking in these particular problems. Now, what if we were given an equation like we were on the first slide and we want to find the axis of symmetry without graphing? Can we do that? Well, the answer is yes. And the way we would do that is using the axis of symmetry formula, which is x equals -b divided by 2a. Helpful to remember, that standard notation of quadratic is ax squared plus bx plus c. Now, does this look familiar at all? It looks similar to the quadratic formula, which was x equals -b plus or minus the square root of b squared minus 4ac all over 2a. And if I were to split this up, I could write it as -b over 2a plus or minus the square root of b squared minus 4ac all over 2a. And this piece right here is the formula for the axis of symmetry. Now, if you think about this for a second, it actually makes a lot of sense. What we were finding with the axis of, with the quadratic formula rather, are the points where the y value is 0. We were solving equations with the quadratic formula. Well, when y equals 0, for those 2 points, we have two symmetric points. And even further than that, they would both be x-intercepts. Well, if they both have 0 as their y value, they're symmetric to the axis of symmetry. They're both the same distance away, one to the right, one to the left. Well, -b over 2a is the axis of symmetry, and then we have that plus or minus feature of the quadratic formula, and we're adding and subtracting the same value, whatever this value is. Well, think about that. If we're adding 5 and subtracting 5, we're going the same distance, one to the right, one to the left, of the axis of symmetry, of the middle of our graph. So that's why if we isolate the -b over 2a, that's going to define the axis of symmetry for us. So let's actually use this formula now. So determine the axis of symmetry of the given quadratic equation algebraically. So y equals x squared plus 2x minus 8. So a is 1, b is 2. So the axis of symmetry is x equals -b, so -2, over 2 times a. So that's -2 over 2. So x equals -1. Which is exactly the axis of symmetry we found when we graphed this function in the first example. Now, how can we use the axis of symmetry to find the vertex? Well, we should know now that the axis of symmetry goes through the vertex, through the turning point. So that means the vertex has an x value of -1. Then we just need to find the y value. Well, if I gave you an x value and told you to find a y value, you would input that x value into your function and simplify. So y equals positive 1 minus 2 minus 8, which is negative 9. So the vertex is negative 1, negative 9. We can again confirm this. Go look at that first graph we created. The vertex, the turning point, was exactly negative 1, negative 9. So at this point, we've done it graphically. Create a table of values, or I give you a graph. We found the axis of symmetry given symmetric points, and now we found the axis of symmetry in the vertex algebraically. Let's do a little bit more practice with the algebraic piece. For each of the following quadratic functions, find the axis of symmetry and vertex. So y equals x squared plus 8x plus 12. So the axis of symmetry is x equals negative b, so negative 8 over 2a. A is 1. So that's going to be negative 8 over 2. So x equals negative 4. Another reminder, the axis of symmetry is a vertical line. We need to write the equation as x equals negative 4. If you just told me the axis of symmetry is negative 4, I wouldn't know exactly what we're talking about. X equals negative 4, y equals negative 4, a point with the y value of negative 4. And we have to be as specific as possible. And then to find the vertex, well, we know the x value is negative 4. We need to find the y value. So we'll substitute negative 4 in for x. So negative 4 squared plus 8 times negative 4 plus 12. So we have 16 minus 32 plus 12. So that's negative 20. Negative 20 plus 16, that's negative 4. So negative 4 is the vertex of this particular function. Here, axis of symmetry, x equals negative b over 2a. So that's going to be positive 2 over negative 2. So x equals negative 1. And then the vertex is the point with the x value of negative 1. So y equals the negation of negative 1 squared minus 2 times negative 1 plus 3. So y equals negative 1 squared is positive 1. And then we have minus 1 plus 2 plus 3. So that's 4. Okay, so we found the axis of symmetry and the vertex algebraically from these two equations. Now here are the graphs of each of those. Y equals x squared plus 8x plus 12 is a parabola that opens up so that the vertex is a minimum, and y equals negative x squared minus 2x plus 3 is a parabola that opens down so that the vertex is a maximum. So is the vertex for each parabola a maximum or minimum? So for our first one, we said that it's a minimum. And our second, we said it's a maximum. So the next question is, how can we tell from an equation if the vertex will be a maximum or minimum? Well, if we look, let's look specifically at the x squared. Positive x squared, the parabola opened up. Negative x squared, the parabola opened down. So that value of a, the leading coefficient, dictates whether a parabola opens up or opens down, which then will define whether a vertex is a maximum or a minimum. So how can we tell? The a value. So a minimum happens when a is greater than or equal to 0, positive, not equal to, that wouldn't make sense. Let's fix that. When a is greater than 0, and a maximum happens when a is less than 0. Okay, so let's look at a few more. For each of the following quadratic functions, find the axis of symmetry and vertex. Determine if each vertex represents a maximum or minimum. Okay, so right here, fx equals x squared minus 9. So we'll start with the axis of symmetry. So x equals, well, there's no b value, there's no x. So that means b is going to be equal to 0. So negative 0 over 2 times 1. Well, that's just going to be negative 0 divided by 2, or x equals 0. Then the vertex is the point with an x value of 0. So if we substitute 0 in, we'd have 0 squared, which is 0, minus 9, which is negative 9. And then lastly, does the vertex represent a maximum or a minimum? Well, if we look, the leading coefficient is positive. So 1, that's positive. So that means the parabola opens up, which means our vertex is a minimum. In our other example, fx equals negative 3x squared plus 4x plus 11. We'll start with our axis of symmetry. So x equals negative 4 over 2 times negative 3, which is negative 4 over negative 6. So x equals 2/3. Next, we'll find the vertex, which is the point with an x value of 2/3. So for this one, we're going to need to do a little bit of work. So we have negative 3 times 2/3 squared plus 4 times 2/3 plus 11. So we have negative 3 times 4 over 9 plus 8 over 3 plus 11. So this is going to be negative 4 over 3 plus 8 over 3 plus 11, which is 4/3 plus 33 over 3, which is 37 over 3. 37 over 3. And the vertex, because the leading coefficient, the a value, is negative, that means the parabola opens down, the vertex is a maximum. Last question. What is the domain and range of the given function? f of x equals 2x squared minus 6x plus 7. Well, we've graphed a few parabolas and looked at the graph of a few parabolas in this video. And what we noticed is we can plug any x value from negative infinity to positive infinity into this function. Okay, so the domain is easy to answer. That's negative infinity to infinity, or all real numbers. The range, well, this parabola opens up, something like that. So if we can figure out what the y value of the minimum point is, then we know the range is anything equal to or greater than that y value. Okay, so how are we going to do that? Well, first thing, we have to find the axis of symmetry. So that's x equals negative 6 over 2 times 2. So 6 over 4. So x equals 3 over 2. Now we need to find our vertex. So x is 3 over 2. We need to figure out the y value. Again, we have some work cut out for us. So we have 2 times 3 over 2 squared minus 6 times 3 over 2 plus 7. So we have 2 times 9 over 4 minus, let's see, 6 and 2 cross out, that's a 3, so minus 9 plus 7. 2 and the 4 cross out, so we have 9 over 2 minus 2, which is 9 over 2 minus 4 over 2, which is 5 over 2. So that means the range, the lowest y value is 5 over 2, and any y value that's greater than or equal to it. So we'll use interval notation, so bracket 5 over 2 to infinity. And that was because the vertex was a minimum. Right? It would change slightly if it was a maximum. That y value would be the highest y value in the range. So we'd be going from negative infinity to that y value. a lot of concepts here. Two focal points, axis of symmetry and vertex, but we've looked at them in quite a few different approaches. Graphically, given some information about symmetric points, and then algebraically with x equals negative b over 2a, and then defining whether a parabola opens up or down with that leading coefficient. Okay, so watch whatever pieces you need to a second time, and then practice. That's the best way to really understand these concepts, which will be really helpful as we move throughout this unit. Click the Amazon link down below for my algebra workbook so you can practice on your own. Give the video a like, and before you go, click that subscribe button so you can see more videos just like this. Thanks for watching.